All right, guys, welcome back to Cisconate. We got a lot to cover today about something that probably keeps all of us up at night, and that is how to build a VTI tunnel between Azure and FTD. So it sounds simple, and in principle it is, but there's some devils in the details when it comes to how these two massive technological domains use different terminology to refer for different components. And that's because, principally, they are built on different paradigms. Cloud technologies are built to abstract all of the underlying fabric and configuration from you, where you essentially kind of just configure your intent, your policy, and it does all of the stitching underneath. So on cloud, for example, you will not have next hop IPs for routing. You will just say where to point it. Point it at my virtual network gateway. Point it at the virtual network. Stuff like that. Whereas the firewall security appliance domain, you have standard routing, where you set up static routes with a next hop. And that actually is functionally how a lot of this will work in a very cool way, as you'll see as we get along here. So I've only got like an hour to get this done. Let's get moving quick because some of the components take a little while to deploy on Azure. So the first thing we want to do is have some solid planning. And so I'm going to start out here by drawing up what we plan to do. I'm going to do pencil with black. We're going to draw our Azure over here. Azure is obviously the Azure Microsoft Cloud. And then we're going to draw my home, i.e. the spoke over here. And this is going to be kind of what you guys end up dealing with. Now within Azure, we have what's called a VNET. And a VNET is kind of like the large IP address space you're going to be using for deploying this stuff. So we're going to set that as 10.1.1.0/16, a big /16. And within that, we're going to need a few subnets carved out, namely the data subnet, which I'm going to call a VM because I'm going to stand up a VM in there. And I'm going to use that VM to prove to you that traffic is indeed flowing over this tunnel properly. Now within Azure, they also have these other constructs called Bastion hosts. That is their de facto way, their best practice way of accessing a VM when you have it deployed. And since I have a VM, I'm going to deploy Bastion. Now, underneath that technology, they also deploy a bunch of other optional services. So for Bastions, you are required to spin up a separate segmented Bastion subnet. So we're going to make this 10.1.3.0. And an astute observer might say, hey, why'd you skip 2? And that's because, once again, for each discrete component, many of them require a special subnet carved out. And in this case, when you have a gateway, a virtual network gateway, it requires a gateway subnet. So we're going to allocate that as 10.1.2.0/24. Now attached to that gateway, you have to give it an actual network gateway, virtual network gateway attached to the gateway subnet. So we'll say this is called a virtual network gateway, a VNG. And that VNG is going to have a PIP, public IP address. At this point, we don't know what that is, and we won't know until we configure it on Azure and it dynamically allocates it. And that's fine. We can get away with our planning without that component. The last thing we are going to have is what they call a connection. And the connection is essentially your VTI configuration. Now, in combination with the connection is a special thing called an LNG. And the LNG literally is essentially just the, hey, where's the next hop for the VTI and what's the protected routes or subnet? Now, we haven't defined that yet, so let's go do that real quick. Over here on the spoke, I'm going to use 10.2.0.0 as my /24 subnet. I'm going to be running a firewall here, FTD, and it's going to have the subnet of 71.191.137.80. So, my next hop IP address is going to be 71.191.137.80. And then my secured routes are going to be 10.2.0.0/24. This connection here is going to be our VTI. And just for planning's sake, on the FTD side, we need to assign that a subnet, 172.16.0.0/30. And the 172.16.0.1 is going to be assigned to the FTD side of the VTI. Now here's where it gets kind of crazy. You see, according to RFC 4301, the IPsec architecture, All that's required is that you get a packet into that tunnel and it is automatically on its way to the other end. What that means is you can have two discrete subnets defined on either end of the tunnel and they don't actually conflict. They don't care. I.e., on this side over here, I could assign it 10.0.0.0. And the FTD would be none the wiser and wouldn't care. As long as a packet made it into the tunnel, it would get there. Now, in practice, Azure doesn't really kind of expose this. There is a way to figure out what IP ultimately they assign to your tunnel, but it's not necessary. So just a small bit of information there because it is kind of interesting. Now we have two more things we have to concern ourselves with, and that is we're going to have a route table on the Azure side. We're going to have a route table on the Spoke side, and they're going to look a little bit different. On the Spoke side, you're going to say, hey, to get to the 10.1.1.0 subnet, go to the VTI interface to the next hop 172.16.0.2. And our device knows, hey, that's in the VTI. It'll put the packet in the tunnel, and that's enough. It gets to the other end. On the Azure side, you're going to say, hey, to get to 10.2.0.0, go to my virtual network gateway, VNG. You literally don't have a next hop IP. You just tell it, send it to this interface. So the route table looks different. The last thing we're going to have is what we call network security groups, which are Azure's way of defining ACLs. So on the Spoke side, we're going to say outbound allow 10.2.0.0 to talk to 10.1.1.0 and the inverse, 10.1.1.0 to talk to 10.2.0.0. Same thing is going to happen on the network security group side. You're going to define an outbound rule though. Instead of them all being collapsed together, there's an out and an in. In the outbound, you're going to say 10.1.1.0 can talk to 10.2.0.0. And inbound, you're going to reverse that. And notice I didn't separate that on the FTD side because there's no concept of a separate inbound or outbound area. You can segregate the rules into groups like that, but it is not enforced. Whereas in Azure, it is enforced. So we have our route tables. We've got our ACLs, we got our LNG, we got our connection VNG, VNET, all the subnets. We got everything we need here. We have a solid plan. So let's actually move on to implementing this, all right? When we look at implementing this, on the Azure side, it's create the VNet, create the subnets, local network gateway, virtual network gateway with the public IP, the route table, network security groups. I am going to spin up those other optional components, Bastion and VM, and install ping so that we can ping across this to prove that it's working. Now, the virtual network gateway takes the absolute longest to configure. So I'm going to start there and get those things moving. And actually, let's take a step back. I'm actually going to start by creating a resource group. Now, this is important because a resource group helps you quickly shut down everything without having to understand what has dependencies on what. It does the dependency mapping for you. You say delete resource group and it will gracefully automate and delete all of those dependencies to get rid of everything. So I want to call this RG for route resource group Azure VTI. I'm going to hit next, no tags, review and create. Let's create. Now this happens fairly quickly. So I'm just going to refresh here till it shows up. And about another second it should. There it is. So we're going to start off by trying to create, well, we're going to create the VNet first, virtual network. Now I use this search bar up here because it gives you everything. The marketplace doesn't work that well. So virtual network, virtual network. I'm going to create a virtual network in my Azure VTI resource group, and I'm going to call it VN for virtual network, Azure VTI. I'm going to hit next. We're going to say, yeah, let's go ahead and enable a Bastion. It's going to create a Bastion host for us with a public IP. Now, there's no way to say no public IP. I really dislike that. I'm going to let it stay, but at least that'll get the Bastion host spinning up as well. We're going to hit next. We have to change our subnet here to what we planned out, right? 10.1.0.0/16. So let's do that. Now, because it tried to automatically create a Bastion, it also tried to create the Bastion host subnet. And that is stealing the IP address that is currently supposed to be assigned to my default subnet. So we're going to go ahead and work backwards here. Azure Bastion is the purpose. It has a fixed name. You cannot change it. It falls within our VNet, and we're going to change this to what we assigned it, which was 10.130, and I'm going to set it as a /24 just because that's what our plan was. We're going to hit save. Now that that is changed, I can come change this. And I want to give this an appropriate name. I'm going to call it Subnet because I like to use the names that mean something, VM. And I'm going to come down here and assign it to the subnet that I intended, which is 10.110/24. We're going to hit save. And I'm going to create one more subnet here. And this is the subnet intended for that virtual network gateway, which has a forced name of gateway subnet. And the address we chose for that was 10.120/24. So we have all of our subnets and the VNet. We can hit next, next. It's going to review, and then we hit create. Great, we are on our way to creating exactly what I need. And that stuff happens pretty quickly. So if we come back here, we've now created the VNet and all the subnets within it, including spinning up the Bastion host inside of the Bastion, which also spins up the Bastion NIC. So that's wonderful. We can now come here and either create the NSG and start working on that, or create the LNG. So let's see what we can do here without violating anything. I'm going to come up here and say local network gateway. I'm going to hit create. We're going to put this in our resource group. We're going to call it LNG. We're going to tell it the IP address. The IP address it's looking for is the public address of your other hop of the VTI. So 71.191.137.80. And then the address space that's asking for is what subnets do you want to secure? 10.200.24. Fantastic. We're going to hit next, go to advanced, make sure we're not doing BGP settings. Hit create. Now we're going to go ahead and start firing off the virtual network gateway because it is going to take a very long time. Now we want to set up a VPN, virtual network gateway, and we want to use the VPN gateway option. We're going to create one. We're going to associate it, call it VNG Azure VTI US East. Why is it not? Here we go. Virtual network. Okay. We're going to choose VPN GW1. The default they give you is 2, and that's a $387 a month charge. We don't want that. We're going to go with 1. There is a smaller one developer, but you can only do it via Azure CLI or PowerShell. So this is as good as we can go with the web GUI. We're going to go ahead and choose the virtual network as that. We're going to say create a new address, a new public PIP public address for this external Azure VTI. We're going to say disable active. Otherwise, it's going to try to create 2 for load balancing and active. We don't want that. We're going to say disable BGP, and we're going to leave key vault access at disabled. So we have everything we need here with good nomenclature. We're going to move on, review and create, and we're going to hit create. Now this is going to take an extremely long time, on the order of like 30 minutes. So we're going to move on to configuring some other components like the network security group, and then bouncing over to configure the FTD side of things. So let's come back here. We're going to go network security group and choose our Azure VTI, NSG, Azure VTI in the US East. Now, it doesn't let you create the rules yet. It just lets you create the object. So we're going to hit create. And this is relatively quick, right? Creating the NSGs and the routing tables are quick. We can't do the routing table until the VNG is up. And we can't do the connection or the PIP until the VNG is up. So these 3 items are stuck behind the VNG. We've created everything else that exists here, but we haven't populated the NSG. So let's go ahead and do that. It is now done. We can hit go to resource. The inbound rules. This is inbound with respect to Azure. So 10.2 coming to 10.1. So we're going to go ahead and add that rule. Inbound. Source IP address 102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.102.168.1 10.1.10/24. Going to leave this as any protocol, any port, allow, and we're going to say this, allow spoke to VM. Come down and hit add. Once that's added, we're going down to the outbound and mirroring that rule, heading the other way. So we're going to say, hey, from Azure 10.1.10/24, any port can go to 10.2.00/24 on any port, any protocol, allow VM to spoke. Add. All right. We have now created our NSGs, but it's just an ACL sitting there. It's not applied to anything. So we're going to come down to our subnet, and we're going to associate it to the subnet VM under the VN Azure. Perfect. We're going to hit OK. Nope, that just means the VN's not completely done yet. So we'll come back here, look at this. This happened last night. Azure is a little bit slow sometimes. We're going to look at our resource group and all of the resources in it. We've got our LNG, our NSG, our PIP for the VNG. We got our VNG coming online. The way you know is if you click it, it'll say updating. And it's going to say updating for probably about 30-40 minutes here. At that point, you can then create a connection and reference the LNG, and it will assign itself a PIP. Now, we do have the PIP already assigned. That is good. You can use this. So we're going to go ahead and grab that. And at this time, it might be a good chance to dive into the FTD configuration side of things. So let's go ahead and get that up and running. I'm going to switch over here to the FTD. So I'm on the FTD side, and I'm using the cloud delivered firewall through Cisco's security cloud control. Once I'm here, I'm going to need to do a few things, kind of some pre-planning. We talked about, we got our subnet here. I already have an interface. That's a local LAN interface here. I've already got a WAN interface. Now I'm actually behind a home firewall. So I've created a DMZ and passed all the traffic destined to this port to my firewall. I need to set up the VTI. And to set up the VTI, I need to set up my VTI interface. I need to set up my crypto selections. So we're going to start from the ground up. First, we're going to add the VTI interface. It's going to be static. I'm going to call it my Azure VTI. I'm going to give it a security zone of Nate's VTI. It's not super relevant. We're going to give it a tunnel ID of 1. We're going to source the tunnel from the outside interface, which currently is a DHCP interface. We're going to go IPv4. It says IP address, configure your IP. This is the virtual IP we were talking about here. So I'm going to go ahead and call this 172.16.01/30. We're going to hit OK. And it's going to create that tunnel. Now that's just kind of the skeleton, the bare bones. Nothing else is going to happen at this point. So what we need to do is a few things. We've got a tunnel, which means we can now create routing. We need a static route, similar to what we planned earlier here, that says use the VTI interface, go to this destination for this guy. So we're going to do that. We're going to say use the Azure VTI interface. We don't have an object here created yet, so we're going to create one on the fly. We're going to call this Azure VM. We're going to call it 10.1.10/24. We're going to hit save, and this creates the Azure VM subnet object. So I can say, to get to that address object, go to your next hop. Now my next hop, according to our drawing here, is the other tunnel address. And that doesn't exist yet, so I'm going to once again create a new object. I'm going to call it the Azure VTI IP. We're going to call this 172.16.0.2. That's right? Yeah, 2. Hit save. There we go. We're going to hit OK. So that is now our static route. Remember to click save. Always click save. It's queuing up the changes for the deployment. And there are dependencies, like you have to have that VTI interface before you can set up routing. At this point, we've got that created. We've got our route. We've got the interface. Now we need to create the policy for secure connection, site-to-site VPN. And this is where it can get fun. So we're going to call this the Azure VTI VPN. We're going to choose route-based VPN, and it's peer-to-peer from the FTD to Azure only. We're going to hit create. We're going to choose our local device, the FTD. We're going to choose the virtual tunnel interface that we've already created. Now this is going to try to pull the current external facing IP and pre-populate it. It's fine. Sometimes it errors out. It doesn't matter. You can just manually configure what you need to once it's done trying to pull this. So while that's happening, we're going to go ahead and check this real quick. And again, it's going to take a very, very, very long time. So still going, which means we cannot do our route tables, our connection, or anything yet. So we're going to come back here. There you go, error finding IP. And that's perfectly fine. Enter IP to be used as tunnel destination on the remote peer. This IP is auto-populated with the currently signed IP, but it can be overridden by the user as required. Use fetch IP to obtain the current IP address on the interface if the IP changes. Use as the remote destination on the other side of the peer. Now we're not doing BGP, so this is not super important, but the IP the other side will expect in this configuration is my WAN IP. So 7.171.191.137.80. It doesn't matter that this is not your actual physical Ethernet IP that it's sourcing from. We're going to come over here and choose extranet. We're going to name this like Azure PIP. And we're going to put the Azure IP address here, which is the 57 address we pulled earlier. So that is done. We're going to go to IKE. I'm not going to use any of this that's already pre-configured here. We're going to create our own new policies. So we're going to delete this. We're going to create a new object. And we're going to call this Azure, what is this? IKE v2 policy. Priority 10. This should be 20,800. It is unchangeable because Azure uses it hard-coded. It's a hidden value that does not change. We're going to come select 256 integrity. Just a note, if you choose a GCM cipher, those include integrity already because they are an AEAD cipher. It includes integrity. So technically, you will run into a deployment error if you choose a GCM cipher and an integrity algorithm. So I am going to avoid that by choosing AES 256 and choose my SHA 256. If you do choose GCM, you can go down and choose null for integrity. That's how you get around it. Now, Azure is really confusing because when you choose GCM, it's still going to let you choose an integrity and it will not complain. It will just silently discard that option. We're going to go to a PRF algorithm, use SHA 256 as well, and Diffie-Hellman group 14. Oh, I did not name that well, and I can't change it now, so I'm going to leave it for now, but we'll name the other one more appropriately. We're going to go to pre-shared key, manual, Cisco 123 with a capital C, Cisco 123 with a capital C, and we're going to move on to the IPsec configuration. Now here we're going to do the same thing. And we're going to change this policy here. We're going to remove this. Oh, look, I forgot to delete one. Okay, well, I'll just add that. But what this really has under the covers is SHA 256 and encryption at AES 256. And that is because for some reason, Azure doesn't go above SHA 256 for the IPsec proposal site. So I've already got the algorithm there. We're good. IPsec, I believe, is 27,000, but it defaults to 28.8, so 27,000. And then we're going to go to advanced. And what we're going to do here is remove the peer identity validation because we're not using certificates or anything. And we're going to hit save. And as long as I didn't screw up any of those IPs, that means we've got our IPsec, we got our ciphers, we got our source, we got our VTI. What did we not do yet? We did our routing. We did not do ACLs. So let's go do that. We're going to go to the ACL policy applied to this firewall, which currently has nothing. I'm going to click add rule. We're going to call this allow spoke to VM. We're going to choose networks. The spoke subnet is 10.2.0.0/24 as the source. The destination network is the Azure VM subnet. Put in as destination. Notice it's 10.1.1.0/24. We're going to hit apply because it's allow. We're not going to do anything special, no logging or anything like that, because this is simply a proof of concept. And this one is going to be allow VM to spoke. In which case, we're going to go to networks and reverse those rules. We're going to say VM subnet is the source, NAT subnet is the destination, allow, hit apply, and save. So at this point, we have ACLs, we have routing, we have VTI tunnel, we have a VPN config. Everything should be good. We should be able to go to deploy. And rather than pushing this right away, we can just come down here. Whoops, I hit the wrong thing. I'll do advanced deploy, sorry. You can go to advanced deploy and you can look at what's pending. We have an ACL pending. We have an interface config pending. That's the VTI. We have the static route that uses the VTI, and then we have our actual VPN with the ciphers configured here. This looks good. So we want to hit that and hit deploy. Configuring. Whoa. Azure. Oh my God, I can't type. Azure VTI. And deploy. This is fantastic. Everything is going the way we want. While that starts deploying, we're going to go ahead and move on from that. At this point, the VNG is still pushing. I'm going to go ahead and pause the video, and we're going to step away until the VNG is done so we can complete the rest of this setup. I'll see you guys in a few. Have a good one. All right, guys. So in order to not waste time, we're going to come back for a minute and check things out. First thing is our FTD deployment was completed successfully, so everything should be configured there. Now I have a laptop sitting on the other side on the private 10.2.0 subnet. Got an IP, I think it's .2 or .4 or .5 something. Either way, I have something there with rules enabled to allow it to act as a responder to traffic, in this case likely ping. Now the VNG is still deploying, but we have one more thing we need to deploy, and that is our virtual machine. So I can come here, I can choose deploy virtual machine. I can say create a virtual machine. I can put it in my RG, my resource group for Azure VTI. I can call this VM Azure VTI, again prepending with VM because that's a virtual machine. We're going to choose availability zone. We're just going to leave it self-selected zone, zone 1. We're going to put this at standard. We're going to use Ubuntu Server 2402 minimal, so it's as fast as possible getting installed and up. We're going to leave it at the default, which is the lowest price. We're going to choose to use SSH public key, Azure user. We're going to generate a new key pair, VM Azure VTI key. Let me just make sure I don't have any. No, I don't. Okay, good. And SSH, select all ports. We're going to go to disk, default 30. We're going to choose HDD because we don't need anything super fast. We're not doing anything crazy. Networking. Put it on our virtual network. We're going to put it in the VM subnet. We don't need a public IP. We're not going to have any security group on the NIC because we're going to rely on the subnet. We go to management. Auto shutdown, 7 p.m., just so we don't get charged a lot in case I forget. Don't need any monitoring. Don't need any advanced configs. Review and create. And we're going to create. And this is likely going to happen faster than the VNG finishes. All right, so Azure VTI, we're going to save that here. Good stuff. And we're going to use that whenever we want to access this VM. It's the standard best practice way, and there is a way you can do it using the GUI and the Bastion client. So we're going to come down here. We're going to look at our resource group, look at everything that's in our resource group now. got an LNG, NSG, a PIP, a VM with a NIC. We have a key. We have a disk, virtual network with the subnets. We have a Bastion. We have a PIP for the Bastion, which I don't need. I don't care about. Doesn't really matter that it's there. It won't hurt anything. And virtual network gateway. So let's go see if VNG is done. Nope, still updating as expected. Let's come back to our resource group and see if our VM is close to finish, because it's pretty quick deployment. There it is. Oh, it looks like it is. So we're going to come down here and test this out. We're going to go to our Bastion. We're going to choose SSH from private key. The username they gave us was Azure user. We're going to select the file we downloaded, which is acting as our private key. We're going to hit connect and see what we get. Great, we're in. We're going to sudo directly to root because we need to do a few things. We're going to do apt update to update the installs so we know what we can install. And then we're going to install, because it's minimal, it has literally nothing, not even ping. We're going to install utils ping, or IP utils -ping. So apt install IP utils ping, I think it is. Yeah, great. Okay, that was it. Now I'm going to do a few things just to check stuff. Azure automatically inserts routes, so I'm going to see what address I have here, 10114. That's great. Do IP R to find out what routes, and these are the routes that Azure is natively inserting. So I know I can go to my gateway and then it goes wherever else it needs to go. This is great. This machine is up and running. I've got what I need. Fantastic. Let's come back to the resource group and see if the virtual network gateway is done. Still updating. Okay. We know on the FTD side, everything was deployed properly. So let's come over here, hit site to site, see what we got. We got a tunnel. It will not come up. It will show inactive, or excuse me, it shows unknown. Unknown is when it's not working at all. Like we have our configs there and it doesn't see anything on the other side. Inactive means the tunnel's established, you're just not sending traffic. And active means the tunnel's established and there is traffic recently going over it. So we don't have a lot to do here. We've already got all of this set up. We got my machine upstairs. We are still waiting on this virtual network gateway. So I'm going to pause here and we'll see you guys again in another minute. Oh man, guys, am I excited. So we started this process for the virtual network gateway at 1:02 p.m. Eastern Standard Time. It is now 1:48 p.m. I've been watching this thing like a hawk and it just finished. All right, so this is great. Let's refer back to our diagram. We got our VNG, we got our PIP, LNG, routing, NSG, all the subnets. The only thing we need left is to build the connection for the VTI. And since this is finally done, I can come down here to connections. We can click add, select our Azure VTI. We can do IPsec, site to site. We'll call this con Azure VTI. We'll hit next. Choose the virtual network gateway that finally just finished. Choose the local network gateway, which is the selector that says what subnets need to be protected and the actual WAN IP next hop. We're going to do a pre-shared key of Cisco 123 with a capital C. We're going to use pre-shared key. We're going to use IKE v2. We're not going to use a private address or enable BGP, but we are going to go custom for IPsec. We're going to choose AS256 here, SHA-256 here, Diffie-Hellman 14 here. For IKE phase 2, for IPsec itself, we're going to do AS256, SHA-256, because that's as high as it goes, and PFS group 2048. Now, the PFS group 2048 is the same as Diffie-Hellman 14. So if we come take a look at our configuration here, back when we configured this, let's see, where was that? It's under this policy, actually, I believe. So we're looking at the IPsec. We'll come over here. Lifetime duration of 27,000, that's right. And it's this, AS256 for encryption. Let me just make sure that's right. Yes. let me just go look at the object so I can view all of it without changing anything. So we're going to go down to VPN, go to our IPsec. Yep, so it's AES 256 for encryption, SHA-256 for the hash. That's perfect. That's what I wanted to verify. We're going to come back to the site-to-site VPN view and watch this little diagram. All right, so all of this is set up correctly. We want to leave it as default connection so either side can initiate. We do not want policy-based. We want to use route-based, so we're going to leave this disabled. Lifetime is 27,000, matches what we just saw on the other end. It looks like we are good. We're going to move on to tags, and we're going to review and create. And we're going to create. Fantastic. Now, I don't know how long this goes. It's longer than like some of the virtual network stuff, but it's faster than the virtual network gateway for sure. Use local Azure IP address. I don't know what that's talking about. Let's go see what it's talking about. Where's our connection? Oh, it didn't even give us one. Let's go back to the VNG. Add. Perfect. I must have clicked something funny. Con Azure VTI, US East, settings, VNG, local network, pre-shared key. C0123. We don't want to do that. We want to do custom. 256, 256, 14, 256, 256. 2048, i.e. 14. We did not use private address. Make sure it still did not choose a private address. Good. Create. I don't know what happened there. I haven't seen that error before. That was odd. I must have accidentally clicked something and wasn't paying attention. Who knows? There you go. It says created. Well, deployment's in process. We go back home. We're going to go look at virtual network gateway. There you go. It's updating. Not quite done yet, but it's getting there. So this does take a minute or two for this one, but it's way faster than the VNG, which took about 46 minutes, 102 to 148. All right, so at this point, I'm going to hop back over here, and I'm going to say ping 10.2.0.2, which should go through and try to hit the other end. There's a few things we can do while we're waiting for this to finish deploying and bring the tunnel up. And I will show you how to do that to verify some of this stuff. We're going to pull up what's called a network watcher. Network watcher is their internal tool. Okay, deployment is done. So my ping should continually try to bring up traffic. But I'm going to first go to flow verify. We're going to choose our machine, choose network interface. Yep, that's fine. I don't need local port. We'll choose 6000, random ephemeral port, going to remote address 202. We'll do remote port 443. Well, that's interesting. Why is it complaining? I've never actually had to deploy an NSG attached to a NIC before. But if it is going to do that, I can come here and associate it with the NIC as well. We have associated with the subnet. Oh, it didn't get associated. I'm pretty sure I deployed this with you guys earlier. Okay, that is now applied. Well, now this makes me question, are the route tables applied properly? Inbound, outbound rules, subnets, it is associated. Let's go check our route tables just to make sure something didn't slip through the cracks here. We should see an RT. Oh, I didn't create the route table because we didn't have a virtual network gateway yet. This is going to cause problems too. So let's go create the route table. VNG first. Now that's finished, we need to create this route table. All right, so we're gonna go back to our resource group. We're gonna call this RT Azure VTI. Propagate default routes, gateway routes. That's great. Next. Now that it's created, we can actually add some specific routes. So we come down to here and we can say, hey, we'll call this route spoke. Destination type is IP address 10.2.0.0/24. Next hop is the virtual network gateway. Again, no layer 3 IP address. This is not a route switch or firewall next hop deal. This is using cloud constructs. And now that we have that route created, we can come down to the subnets and associate that route with the VM subnet as well. It's the VM that needs to know how to get through a VTI tunnel. Okay, so we've got a route table associated. We've got an NSG associated. We've got the VNG, the connection, LNG. That looks like it. I know on this side we did the routes and the ACLs all in one go because we didn't have to do this virtual network gateway construct and wait. So now let's go back to Azure VM here. Bang, 10.2.0.2. I don't know if that's still the address of my device up there. But now we're going to come back up to our network watcher. Say VM, Azure, local port 6000, 10.2.0.2, remote port 443, just to simulate web traffic. We're going to see what Azure will do. Can it route it, and will the ACLs allow it? And this will give us a response here in the bottom just to verify we got our stuff done correctly here. Success. Perfect. Allow spoke to VM, hit the ACL. All right, so now we're going to say next hop. If we're going from our routing group VM with our VM NIC source address going to 10.2.0.2, next hop, and it should tell us it's our virtual network gateway because that's where it's told to punt this traffic. Again, not a layer 3 construct. Perfect. All right, so that is configured correctly. We are good there. So let's come back to our, and we're going to go look at this guy. We're going to go pull this up here. Look, it's active. That means the tunnel is up. The VTI tunnel is connected and we have traffic flowing. So now if I come back here, I may not have an address of 10.2.0.2 anymore. So I'm going to go check that real quick. I'm going to put you guys on hold and I'll be right back. All right, simple enough, guys. The firewall re-enabled itself on that side. So we have pingability to the host on the other side of the VTI tunnel. And if we look at the FTD, once again, active. So we are good here. Now, if I refresh this screen, the tunnel color is going to update as well. I know it's a little misleading that the color was orange here, but green here. So we are good. We now have traffic live across an Azure VTI. I hope this was fun for you guys. I hope it helps you guys fully stand something up. I'm going to provide a bunch of slides. Let me pull those over here that we've been working with. And part of this is the drawing that we drew out as part of our planning here. So I'm going to go ahead and bring that back up. We're going to capture all of that, throw it into a slide deck here. We're going to copy it, put that back away. We're going to slap it in here. So now it's in the slide deck. Shows you the steps in Azure, kind of gives you a planner so you can plug in your subnets and IPs and keep track of stuff as you go deploy it. Also for the connection diagram. And then some typical questions, which I answered during the video. Why can you select integrity? Well, because Azure exposes it. They just don't selectively disable it and they silently discard it. Why is IPsec phase 1 lifetime not exposed or configurable? And Azure, the 28800, you got me. I don't know why they don't make that accessible, expose it, or talk about it so that it makes sense to you when you're looking at settings on other platforms. And how do you get traffic into the tunnel? You simply put a route pointing to the virtual network gateway. The FMC FTD steps, I have the steps documented here, and I captured them in the video. So we've done all of this with you guys able to see everything that was needed to be done. And on that side, how's that routing possible? Well, this is because of RFC 4301. That's IPsec architecture. And we're going to go ahead and leave this here so you guys can look that up later. But it basically describes how as long as you get the packet into the tunnel, it goes point to point to the other end of the tunnel. It doesn't matter what the actual IP is on the other side. What about sourcing from loopbacks? You see examples of that. And that is possible. It happens. But it normally happens when you have an architecture where you have hub and spoke, and the hub is sourcing from a loopback. That helps for a multitude of reasons. Number one, the source will continually be the same and available. And the other thing is when you change the tunnel's physical source, nothing else changes across the network. The loopback is still sourced from loopback instead of the physical IP address. So you can imagine if you change ISPs and you're sourcing from physical, now you have to go change the other end. When you're sourcing from loopback, it stays being sourced from the loopback. So that's it, guys. I'm going to go ahead and shut this down. Hope you have a good one. All the resources will be in a Google Drive link in the description. Have a good one.